Okay, the first thing that I want to talk about is the homework. So basically, this is the homework that I give to you guys. So basically, this is the homework that I give to you guys last week, right? And you're supposed to submit it by before 10 a.m. today, right? And for number one, any of you here having any problem in this particular things? Okay, this one is yes, it's quite a lot of calculation that we're supposed to do it there, because we have, in this case we have, sorry, in this case we have a lot of sections, 1, 2, 3, 4, 5. There are 5 sections there. Okay, so the calculation is quite long. Okay. And then there are several problematic parts from at this particular part, right? This one, we have to deal with the linear distributed load, and then here we have to deal with the constant distributed load, and here we have to move this particular forces to this particular point. Okay, because by doing so, right, you're supposed to find a reaction here. There will be a vertical force reaction, horizontal force reaction, and moment reaction as well here. And the moment will be double, one due to 5 kilonewton and the other one due to 6 kilonewton. Okay. Actually, this particular problem is not that hard, but the calculation is wrong. That's the main thing here. The calculation is wrong. Okay. And this one is more to the internal forces, right? And about the friction, this is the first problem that I give to you guys, and I believe it's not supposed to be a big problem here. This one, maybe some of you having a problem there. This one, I'm not so sure whether you will have a problem with this one or not, and this one as well. Okay. Any of you here having a problem with especially number 2 until number 5, the friction one? Any of you? Hello? No one? No one having a problem?
The fridge one, sir.
The fridge one. Okay. So number 4. How about the other?
It's quite challenging.
Quite challenging, the fridge one.
I'm kind of confused of like the concept there.
Oh, number. Okay. The fridge. Maybe later we can discuss about it. Okay. How about the other one? Number 5, do you have any problems, Sik?
No problem, sir.
Okay.
I think it's the questions is pretty clear.
Okay, then. So number 3 is quite problematic for some of you. Number 2 is not supposed to be a bigger problem. Number 4 is not supposed to be a big problem as well. And number 5 is not supposed to be a big problem. And I need to tell you guys, okay, as usual, right? Some of this problem, actually, I gave it to the previous years as well. So let me check with this one. Where is this? So basically, if you go to my YouTube channel, right, I actually, if you check from last week, right, the video is already there, but I haven't created the playlist yet, so you have to seek through my my video library, right? But actually there, some of the problem I already discussed it there. So basically, if you want to learn about the dry friction, I already created the playlist for you to study it there. Okay, so the last week video I already posted there, and the discussion about the dry friction last year I already added. I added there as well. Okay. Then there are several problem example. This is the first problem example that we discussed last week, right? About this, yeah, about the crate. Okay, we discussed about it last week. So if you want to learn relearn about this, you can watch the video. Then beside that, yeah, this is some of your homework, right? You can see, right? I believe this is supposed to be number 4 of your problem, of your homework problem, right? I believe that one is supposed to be your number 4 of your homework problem.
Correct, sir.
So if you have if you want to check whether your calculation is correct or not for number 4, or if you think that you have a slight confusion there, okay, you can try to check it there. Okay, the whole discussion on how to solve the problem, I put it there. Okay, and I believe the explanation is clear enough there. Okay, then the same for problem number 5. I put the discussion there as well. Okay, so the free body diagram, and then the the free body diagram and the whole steps to answer the problem. If you have any problem, if you have if you think that you have a problem in solving number 5, you can check it in my video as well. It's in the playlist problem example 2. Okay, so basically the numbering there is supposed to be, it's like it's bit random, because my numbering for the problem example is actually based on the year. So you can see here, this is problem example number 1, 2021. This is actually the problem example that we discussed last week. And here, okay, it's actually the problem example that I discussed last year. So if there is no year, there is supposed to be from the last years. Okay, then if you are confused about the tipping, okay, the tipping condition, you can watch the video about the tipping as well. I discussed quite long about about tipping condition, what caused the tipping condition, and what you're supposed to consider when whether it's when you want to decide whether it will tips or not. Okay, you can watch these 2 videos. Okay, the last 2 videos is about tipping. Okay, and
I have
actually,
a question.
yeah, yes.
And for the fridge one, itu kan the fridge have 2 legs kan. Is it possible for us to move the normal in between the legs instead of to the one of the legs?
That's the difference between the problem that I discussed in the last week, in the discussion of the theory, with this one. For this one, because the fridge only have 2 legs, so the friction can only happen at both legs only. So it can only happen. So it can only happen at A and at B. So you can see, I'm not sure whether I continue the discussion here or not. Wait a minute. Let me check this one.
Oh, sir.
Yeah.
So instead of moving the normal force, you can assume the normal force at one point and the normal force at the another point is different, yeah, then different values.
Yes, correct. So
Aduh.
basically, actually, the answer of so if you are actually eager enough to watch my old videos, right? All the answers of those hard questions is already there. You can see here. This is in the last video of my playlist, right? Although the playlist, to be honest, I just posted like in the last 1 hour, but the video is already there in my library. So basically, if you check this one, the last video of my playlist, right, you can see there the way to answer this particular problem. So I discussed quite clearly there on how to solve it. You can see, like what you said, right, Matthew. Basically, the force is only happening at both ends only, at the legs only. So at the front legs, there is a forces there, normal force and friction force. At the rear legs, there is a normal force and friction force as well. But when the tipping about to happen, okay, the condition is slightly different. When the tipping is about to happen, okay, there will be no normal force or friction force in the front leg anymore, because tipping is about to happen. Can you imagine when tipping is about to happen? Most of the forces, not most of those, all of the forces is supposed to be concentrated on the back, on the rear, on the rear legs, of course. So this is the condition. This is the free body diagram that you're supposed to draw when the tipping is about to happen. Okay, do you get it, Matthew? And the other as well.
Yes, sir. It's a bit confusing at first when you don't know.
Actually, it's not confusing if you see the leg, right? It will not be possible to have a friction force in the middle between legs, right? It's not logical.
Yeah, because at first I was confused because you assume the normal at B. What happens to the there's an external moment gitu, sir.
Okay, but now do you understand about it?
Yeah, because there's still A acting on it, right?
Yes.
Okay.
Okay.
Thank you, sir.
So, yes, no problem. So basically, if you want to know how to solve the whole problem, you can try to check it there. I discussed completely there on how to solve the problem. Okay, on how to solve the problem from the beginning until the end, and I believe here the discussion is more complete than in your homework, because here actually there are two problems that we discuss. The first problem is where before it slips, and the second problem is the condition when the tipping is about to happen, like that. So you can check for the discussion there. Okay, and actually I put another. Wait a minute. I think there are several problems that I discussed there. Sorry. Yeah, this is another problem about the tipping condition, which you can check there as well. Okay, it's slightly more complicated because there are two boxes. The top box and the bottom box, and the force is given at the top box, like that. Okay, although most likely I don't discuss it in detail like that, but you can try to check those videos. So basically, if you are eager enough to check about the on my library, right, YouTube library, all the answer is actually there. Okay, all the answer of your homeworks, most of the answer of your homeworks are already there. Anyone here realize about it when you're doing your homework or not? Ashar, do you realize about it, Ashar?
Yes, sir. The tipping one, right, sir? That you're talking about?
Yeah, no. I mean, not the tipping one, but most of the answer of your homework is actually there in my YouTube video library.
I only realized the number 4 and number 5.
Ah, okay then. So you copy from there then?
Well, not entirely. I also watch the steps too. Not only
Yeah. So basically, it's okay for you to answer it based on my video. It's okay, but when you when you are doing that, as long as you try to understand, it's supposed to be okay. Because the main point here is whether you understand or not about the problem. Yes, sir.
Okay, sir.
Mhm. Sik, how about you, Sik? Do you realize that some of the solution is already there in my YouTube video?
Yes, sir. I actually realized it, but I tried to do it myself first, and then
Try to check it.
sometimes I have different ways, but I got the same answer. So yeah, okay.
Yeah, okay. Yeah, it's good. It's good. Okay. Okay. I think that's all for the discussion on the homework and about those homework, right? About the tipping condition, everything related to the tipping condition, right? It is better for you to check with the YouTube video because I don't want to repeat the explanation again because the explanation is already there, and I believe that the explanation is already clear enough there. Okay, and I think for today, I will try to discuss about another problem. Okay, because there are several problems which is quite interesting that which we can discuss, right? And wait a minute. Okay, wait a minute. Let me choose first. Yeah, I think we can discuss several problems here. Okay, now I think I will start with this one. Sorry, I think I will start with this one. No, I think this one is better for us to do it as your homework. I think we will start with this one. This one is slightly different because it's like a mechanism. Hey, wait. I haven't shared it with you yet. Let me share it with you, guys. Okay, can you see the problem here? Hello?
Yes, sir.
I think the first thing that you're supposed to do right now is to try to understand the problem. Okay, try to understand the problem. Then after that, we will try to solve everything together. And to be honest with you guys, this is actually one of the final exam problems several years ago. So the level of the final exam may be quite close to this one. This one is a friction which is related to mechanism. Okay, so it's combination between friction and machine as well. Okay, try to understand it first. So I think I will try to help you to understand. Okay, so basically, this kind of mechanism, we call it as a double brake mechanism. Okay, which is used to stop the wheel rotation. Okay, how it works? Basically, you just need to apply force at this particular lever. Okay, downwards. The force supposed to be downwards. Okay, when you give a downward force P to the lever here, okay, basically you will force the mechanism to brake the wheel here. So this is the wheel that we want to try to we want to try to stop. Okay, the rotation. So you can see where actually this is combination of machine and friction. So you can see that there is a lever here. The lever have a pin here, and at J there is a connection between this particular lever with another links here.
Sir, sorry
EJ.
to
Yes.
disturb you, sir.
Mm-hmm.
Rizky Dasa.
Mm-hmm.
He's taking the second doses of his vaccine right now, so he wants to permit himself from not entering the class today.
Okay, risky.
He's asking
What
where should he
second-
send the bukti like that.
Oh, okay. I think in that case, he's supposed to just send that one via MS Team personally to me. Just tell him that.
Okay, I'll tell it to him because he's taking
Second dose of what?
second doses of his vaccine, COVID vaccine.
Oh, vaccine. How can he get a vaccine?
Yeah,
Have you got the vaccine?
yeah. I have gotten my first doses. My second one will be on May.
Okay. So anyway, yeah. So just tell him that. Okay. So basically, so this is the first lever, and the first lever is connected to this particular one, another links, right? And EJ there, I believe you're supposed to know what kind of lever there, right? Okay. And then that one is connected to this kind of mechanism, simple mechanism. Okay. Then that one is connected to this lever as well. Okay. So basically, if you push this downwards, EJ here will move downwards. Okay. It will move downwards. So this CDE will rotate a bit counterclockwise. Okay. And because of that, CK, it will move to the left as well. Okay. CK will move to the left. Okay. CK will move to the left because CK move to the left. It will push the brake at I here, and for the other brake, right? Because P is going downwards and E is going downwards as well. Okay. There will be a reaction force at T. The reaction force at T will make it will create a moment which will force the things will push the things here at H. So basically, the double braking will be happening there. Okay. Anyone here wants to help me to answer the problem?
May I try?
Who's this?
Answer.
Azar. Okay.
But I'm a bit like wobbly in the middle, so I hope like I could like get guidance in the way also in the way so I could learn as well.
Okay. No problem. So where are you supposed to start?
I'd say from the LJ level.
L and J level, yes, correct. You're supposed to start from there. Okay, from L and J level, then we can create a free body diagram like this, right? Just simple like that. And we have a pushing force P, K, and then here at J, EJ, what kind of link is EJ?
It's the two force member.
Two force member, yes. For two force members, like it or not, the force will be in the same direction as the member, right?
Yes.
So I think I will assume it like this. This one is FEG. Okay. And at this particular point, there will be a reaction. What I supposed to name it? Okay, then just use N and Y and X like that. Okay, but the problem here, P is not yet known, right? That's it.
Yeah.
The value of
Yes,
P
sir.
is not yet known, right? This is the values that we're supposed to find out, right?
That's right. Oh yeah.
But actually, yeah,
it's
but
not
actually
true.
still okay. Still okay for you to do it from this particular lever. But later, you will find out that the value of FEG here, instead of in the force value, like in the Newton values, you're supposed to find it. What you're supposed to get here, if you do it this way, right? You will get it in P.
I see, as a ratio of P. I see.
Yeah. So all the results there, FEG, and the rest of the results, you will be able to get it in P. And then later, after you reach this particular trump, right? Then you can find out the relation between P and M, because M is known, right? 5 Newton meters. Okay, do you get it?
Right. Yes.
Okay, so basically, you can do it that way, or I think that one is quite okay to do it like that. Okay, then so we will just use Azer's way, right? So later, this is the first free body diagram, right? That we're supposed to solve by using sigma moment at n equal to 0. Then we will be able to find FEG, right? Correct, right? In
Right.
P. So, but the
In
value
P.
will be in P, yes. Okay, then can you calculate it for me, Azar?
Okay, I'll try. So sigma M is equals to 0 at n, and then which way would be positive, sir? Is it counterclockwise?
It's up to you.
Okay.
It's up to you, because it won't matter, right? Later, what we will find out is the relation between FEJ with P. That's all.
Okay.
We don't have to find NX and NY anyway. So this is the only equation that you're supposed to use for the first free body diagram. Because why we don't have to find NY and NX if it's not asked here is because what we need is this particular force in order to calculate this and calculate here the reaction there, right? So basically, NX and NY is not necessary. So what you're supposed to do here for the first free body diagram is just to do the sigma moment at n only, correct, right? Asir?
Yes.
And then try to calculate it. This is the links, right? What's the distance between P and N?
Between which and which? Oh, and
P, yeah, the force P and N.
And oh, that's about 0.8 meters.
0.8? No, N here. 0.15 is one of it is 0.15. So n is here, right?
Oh, at that point, okay. So I need to fix my calculation. 65p.
So it's supposed to be p
It's supposed to be
multiplied by
0.65 over 0.3.
yeah 0.65, then minus, then we will do it in the correct way. Okay,
Oh,
FEJ,
0.15.
yeah, minus FEJ multiplied by 0.15, right?
15. Yes.
Yeah.
15.
Equal to 0.
So
Then what you will get is FEJ is equal to
0.65p over 0.15.
okay, yes, correct. 0.65 divided by 0. Yeah, 15 p like that. What is the value then?
That would be, wait, let me grab my calculator. 4.3 recurring. 4.3 recurring. 4.3 p. So, but it's like 13 over 3p.
Okay, 4.3 like that, right?
Yes.
P. Okay, just put it that way. Okay, so this is the first thing. FEJ, we already define it. Okay, now the next thing that we're supposed to do is what? Asher, after we find out the FEJ,
I think we go to the next linkage, which is the trust
this one,
EJ.
right? Yeah, ECD, right?
Also, we go straight to ED. Oh yeah.
Oh yes, because EJ, we know the value already, right? Here, EJ, we assume it as tension, right?
Yes.
FEJ, we assume it as tension, and it's correct because the value is positive, 4.333 p, which means it's under tension, right? So then we can go directly here, right? Now we try to go there. Okay. So this is the free body diagram. Okay. FEJ is supposed to be tension, right? So tension is supposed to be going downwards, right? Correct, right, Azad?
Correct.
Yeah. 4.333 p. Then what else that we have there, Azad?
There's a pin at C and D. So there we would expect reaction forces.
Okay, at D most likely is supposed to be dy and dx. Okay, at C, how about C?
Cy and x.
Cy and cx. Okay. Now I want to try to fix it a bit for that one, because for this one, okay, it will be just like quite close to the two force member, right?
Yes.
So basically this one CK is either under tension or under compression. So we can just assume CK as a two force member there.
Also, we wouldn't see C as a pin.
Sorry.
So we would like rescind the CY, I guess.
Yeah. No, we don't have to. So we just put this one, FCK. Okay. Azhar?
Oh, okay. I see now.
So that one is two force member. So FCK dx dy. Can we solve this?
I'm sorry, skip. Wait.
There are three unknowns, right? Three unknowns with three equation as usual, right? This is our second free body diagram.
Are there like other circumstances where we go straight like FCK like that, sir?
We have to calculate for this one. We have to calculate all. We have to calculate all, Asher, because dx and dy, we will need to use it to calculate for the this particular lever, this one. So dx and dy is needed as well.
Oh, I see.
Okay, FCK, yes, it's needed to find out for the things which is happening here. So both we have to calculate, and not both. Three of those we have to calculate. Three of those: dx, dy, and FCK. But you can start with either one actually, right? Which one that you want to start first? Which one that you want to find out first? It's up to you. We have all of this. Sigma fy equal to 0, sigma fx equal to 0, and sigma moment equal to 0.
Considering
And using these three,
the least
can
amount
solve for
of
those
nodes,
three.
I think we could evaluate FCK through like moments.
Yes, correct. We can evaluate FCK using sigma moment at point what?
On D.
D, correct. Equal to 0. Sigma moment at point D, then what you will get there?
First is the force, the FEJ force times 0.2.
Now we use this, right?
Yes.
Times 0.2.
And then the
minus
the FCK times 0.1.
0.1 equal to 0. Then your value of FCK is what?
FCK is
twice, right? Twice
yes,
of that.
Twice the value.
8.666, sorry, x.667 p, like that. So FCK is found. Correct, right?
Correct.
Now how to find out dy and dx?
I think we could start with sigma fy equals 0.
Okay, sigma
to find out dy.
Okay, in this case, what we will get is 4.333 p minus dy equal to 0. So dy will be equal to
minus 4.333.
No, not minus. Correct, right? It's supposed to be plus.
Oh, I see. Okay.
Yeah, the direction is already correct. P, right? dy is found. Then using sigma fx equal to 0, this is what you will get, right? FCK, so FCK minus dx equal to 0, right? So
dx will have the same value as FCK.
Yes, correct. So dx will be equal to FCK, will be equal to 8.667 p. Okay, we found the value of dx, dy, and FCK, right?
Yep.
Now the next thing that you're supposed to do, you have to determine whether we want to evaluate this first or this first. Which brake mechanism that we want to try to analyze first, the right one or the left one?
I would say the left one, sir, because
the left one. Okay,
least amount of unknowns.
Not necessarily, both are already there. Okay, all the information is already there. So now the third free body diagram is we are going for the DHA, right? That one.
Yes.
So DHA, most likely we will have it like this. Then this. Sorry. Yeah, something like that. Okay, so basically we will have dx and dy. if dx and dy is going up and left here, okay,
Yes.
at this
We
particular point, it will go to which direction?
the x would go into the bar and then I mean like horizontally like that. Wait.
Yeah, horizontally is going to the right or to the left?
Oh, to the right.
To the right, because action and reaction, remember, okay? So this one is dx. How about dy?
Downwards.
Downwards, correct. This one is dy. Okay, both value we already find it out. Dx is equal to, what is dx here?
Dx is
8.667 p. Dy is 4.333 p. Okay, what are the forces that we have there?
We have the wait. Now that I think about it, we don't have the forces at A. Do we?
Yeah, forces at A. What kind of forces that we have at A? Is that
AX and AY.
AX and AY, correct? AX, AY. What else that we have there?
On
How about at H?
the breaking point, the point where you have to like break it at H.
Mm-hmm.
That
So
will
at
be
H,
like
yes. Supposed to be
like
friction force and normal force, right?
yes.
Okay. What is the direction of the normal force there? Remember, we are talking about the brake, not talking about the wheel, right? What is the direction of the normal force at the brake there, at H there?
Left.
Going to the left, yes, correct. This one is supposed to be going to the left. That one is supposed to be normal force, right?
Yes.
Normal force at H. And what else that we have there?
I think that's all in the bar.
Are you sure? How about the friction?
Oh, right. The friction at H.
Yes.
That would be because the wheel is rotating anti-clockwise. I think it would be to upwards. The friction.
Upwards? Are you sure upwards? Are you sure upwards?
Like relative to our figure right now.
Okay. Yes. If we are talking about the rotation about the wheel, right? The wheel have a moment like clockwise, like that. Okay. So for shear at the wheel, there will be a friction force upwards. Yes. So at the brake, the friction force is supposed to be opposite of that, right?
Yes.
So it's supposed to be. It's supposed to be downwards.
Oh wait.
Because action and reaction, remember. So this one we're talking about the wheels.
So it's upwards at the wheels, but at the
Yes,
bar it's supposed to be. Oh, I see now.
Because it's action and reaction. Remember about that. Okay, this is for everyone. Okay, so whenever we have a movement like this, we're supposed to take a look at the rotation at the movement. So the wheel, okay, the rotation is counterclockwise. The moment is counterclockwise. So the friction is supposed to be forcing the moment to eliminate the moment. So the friction force is supposed to be going upwards. But remember, because the brake at the brake, right? Its action and reaction with the wheel, the friction force here is supposed to be going down. Okay, Asad?
Okay, sir.
Yeah. Okay, good. Then now I think that's all. But how can we solve 4 unknowns with only 3 equations? Asad?
We could do with
What do you think, Asad?
I think we could do with moment n, but that would be result in. But that wouldn't do anything. Wait.
You're supposed to check with this one. The static friction coefficient between the wheel and the brake pads are this one.
0.8.
And we're supposed to calculate the minimum force P to stop the wheel rotation. Actually, it's not supposed to stop the wheel rotation, but I mean, the condition is supposed to be the impending motion. That one. Do you get it? Because the impending motion, the condition of impending motion, it will create the minimum force, the minimum force to prevent the wheel from rotating. Okay. The condition of impending force, it will create create situation of minimum force P to prevent the wheel from rotating. So because that the minimum force here, because there is a condition there, and we have mu s equal to 0.8, then we can directly assume, we can directly replace FH here with NH
0.8.
multiplied by
0.8.
0.8. That's correct. So 0.8 in NH, and for the normal force is NH, right? So now, how many unknowns that we have there?
We would have AX and AY.
And NH, right?
Is NH.
Yeah, so 3 unknowns. We have 3 unknowns, NH, AX, AY. So we will be able to solve it using sigma moment, sigma fx and sigma fy equal to 0. Do you get it?
Yes, I get it.
Good. So now we can start the calculation then. Okay, we can now start the calculation. Okay, what we need the most is the NH and FH, right? AX and AY is not asked there. So as long as we can try to find the NH, as long as we can find NH, it's supposed to be
in terms of P when we
yeah. That's the things that we need, right? NH in terms of P, NH and FH in terms of P. So basically, as long as we find NH and FH in terms of P, that's all for us. We don't have to find AX and AY because AX and AY is not asked there. So basically, for this one, you can just use sigma what? Azad?
Sigma moment at A.
Yes, correct. Sigma moment at A equal to 0. Sigma moment at A equals to 0. What are the things there? What are the things that we have there?
We have dy times
this one, right? There is a 0.1 meters there.
Yeah.
Okay, dy has 4.333 p times 0.1. Okay, so counterclockwise positive, right? Now, what else?
Friction H. Oh, the NH times 0.8. That would be, we would multiply it
Counterclockwise
by
as well.
0.1.
Sorry, and
The NH times 0.8, we multiply it again by 0.1.
0.1. No, we don't have to, because NH. Sorry.
It's
the friction force. Yeah, the friction force is the same direction here. So right? Here it's supposed to be here, right? Friction force, and it's at the same. Sorry, at the same.
So we're left with just the normal one, yes, sir.
Yes, correct. We are just left with the normal one, and don't forget about the x as well.
So that we NH times 0.4.
Yes, NH K plus NH times 0.4 minus
dy times 0.7.
Not dy, dx.
Oh yeah, dx times 0.7.
Okay. Yes, correct. Dx times 0.7. Dx there is supposed to be 8.667. 8.667 p multiplied by 0.7 equal to 0, right?
Yes.
So this is the equation that we have. Now, can we calculate for NH?
Oh, yes, we can.
What is the value of NH there? So
let me try.
0.433 minus sorry, NH is supposed to be 8.667 p multiplied by 0.7 minus 0.433. What is the value there? Divided by 0.4.
With
So
NH is, based on my calculations, NH is supposed to be.
Yes. What is the value there?
5.4 p.
0. What is the value there?
5.4 p.
5.4 p. 0.4. I think your calculation is a little bit miss, because we're supposed to divide it by 0.4 as well.
Oh, I see. Wait.
0.667 multiplied by 0.7, okay, minus 0.4333. Yeah, for 5.633 is correct, right? But you have to divide it by 0.4. So 14, right?
Yeah, I guess it's 14.
14.08 like that. This one is in terms of P, right?
Yes.
Correct. So this one is NH there. NH, we already find the value. Now, if I want to find out the value of FH, what is the value of FH?
0.8 times the normal.
Yes. 0.8 times NH. What is the value there?
Times 11.26.
Okay, 11.27, right? I think it's better to 11.27p. So that's the value, right? We already find the value there, right? We have the value of FH, we have the value of NH. Okay, so FH, we already find out the value there, right?
Yes.
Okay, now we are left with the other lever, right?
The KB lever.
Yeah, KB lever. Okay, so for KB lever, I think keep I think for this one. So now K believer, right? K believer, we're supposed to draw it like this one, then we have it like this, then we have like this. Okay, something like that. So the forces that we have there, remember CK is, we assume it as two force member. FCK is under tension, right? That one. FCK is under tension and the value is 8.667 P. So this one is FCK equal to 8.667 P. What else that we have there?
The normal at I.
The normal at I. Where is the direction there?
Direction is towards the lever, so right.
Going to the right, yes, correct. So normal at I. What else that we have there? How about the friction force?
Friction at I.
Yeah, friction force. Yeah, in order to determine it, remember the moment is counterclockwise. So at the wheel, the friction force there going down, right?
At the bar, it's going to be upwards.
Yes, correct. So always think like that, okay, Azir, and everyone else as well, okay? Try to take a look at the movement, okay? Try to check the friction force that's supposed to be there. And remember, if you have two things which is in contact together, there's supposed to be action and reaction. This one is action and reaction, right? And this one is friction force at I. Okay, what else that we have there, Azir?
The reaction force of Bx and By.
Bx and By. Okay, Bx and By. But Bx and By. But as usual, I will ask you another question. Do we need the value of Bx and By here?
No, we don't. But we could use this as a reference point for the normal.
Yes, correct.
For the moment.
Yeah, so we can just use it like this. Sigma moment at P equal to 0, as the same as before, right?
Yes.
So for this one, because there is no vertical force at K, the sigma moment there will only consist of this and this only, right?
Yes.
Okay, and remember, just now we assume from the beginning that it's the condition in order to create the minimum force there is supposed to be in the impending motion condition, right? So the Fi here is supposed to be 0.8 of Ni. Yes. So in this case, sigma moment at P equal to 0, what are there? Asya?
The FCK times 0.8.
Okay, so FCK is 8.667 P times 0.8. Okay, minus
Ni times 0.4.
4 equal to 0. So what you will get is the value of Ni. What? The value of Ni is twice of FCK, correct, right?
Correct.
Yeah. So what is the value of Ni?
17.334.
Yeah, 17.333 speed. That's Ni. Okay. Now, how about Fi? The friction force. 0.8 of
0.8
Ni, right?
Ni.
So what is the value?
That would be 13.87
times 13.8666. 13.866 B. Okay, so now we know all the values of Ni, Fi, and the previous one we know the value of NH and FH, right?
Yes.
Okay, now we are left with the last free body diagram, Asir. So just now we have the fourth free body diagram, right? This one is the fourth free body diagram. Now we are left with the last free body diagram. What is the last free body diagram, Asep?
The wheel.
The wheels. Yeah, the wheel, correct. The wheel here will be our last free body diagram. And what forces that we have there? Asep, please let me know the complete condition, the complete force and the complete forces and moment that which happening at the wheels.
Both normal forces at H and I with their friction.
And the direction. And the direction supposed to be for NH first. What is the direction?
NH is to the right and NI to the left.
This one is to the left, yeah. This one is NI. This one is NH. And what is the friction force direction there?
Friction H is
this
upwards
one is,
and friction I is downwards.
Yeah. Friction H here is downwards, so it's supposed to be the opposite of that, right? Because action and reaction. So FH. Then this one is supposed to be FI is going, it's upwards here. Okay.
So it's supposed to be downwards at the wheel.
Supposed to be downwards there. It's supposed to be action and reaction. So it's supposed to be downwards here. FI. What else that we have there?
The spinning moment, which is 5
spinning
Newton
moment,
meters.
yes, correct. Okay. Moment equal to 5 Newton meter. What else that we have there? Remember, I want the complete one. What else, Azar? It's not yet complete. Because it's impossible to have it just like this. What do you think at O, Azar? Will there be any pin at O, Azar? If you have a wheels, most likely you will have a pin, right, in the middle.
Oh, that's still part of it as well. Oh, yeah. I see.
That one is part of it. So you have to draw it as well. So you will have OY and OX there. Okay. Now, in order to calculate the relation between the P and the moment, what should we do, Asya? Because we want to find out the value of P, right? And now the P value is not yet known.
I think the moment, all the other moments must add up, must be added, and then when we this the sigma moment of 0.
Yes.
When we add it against
the equilibrium is supposed to be there actually. So sigma moment equal to 0 is supposed to be fulfilled there, right? Remember the Ni, the value of Ni is 17.33. The value of Fi here is 13.866 P, and the value of FH there is 11.27 P. Okay, so now you can just use sigma moment at O equal to 0, right? Okay, what you will have there?
11.27 plus.
So FH, right? FH multiplied by
the
radius, yeah, 0.2. And then plus
Fi times 0.2.
Fi times 0.2 minus M.
Minus M.
Okay. So FH there just now is 11.27 P multiplied by 0.2 plus Fi 13.866 P multiplied by 0.2. Moment is 5, right? Newton meters.
Yes.
5 Newton meters equal to 0. Okay. Can you calculate it for me? What is the value of P here? Quite close to 1, I believe, right?
Yes, and it's supposed to be 3.
It's quite close to 1. So the value of P here
It's
is supposed to
0.994.
Yeah.
0.994.
0.994. What is the unit here?
The unit is supposed to be in
The moment is in Newton meters.
Newton meters.
Is Newton meters. Newton.
Yeah, Newton.
It's supposed to be Newton. So this is it. Okay. Do you get it, Asif?
Yes, sir, but it's quite a long problem.
Yeah, it's quite a long problem, but remember, and this is the things that you will have in your exam. So I mean, in the exam, the problem will be quite close to this one. Okay, sir. But now
Okay.
you understand, right? Good. Remember action and reaction, always like that, right?
Oh yes.
Okay. I think now we'll try to discuss a little bit, just shortly on the other problem. So for the this is another problem, which is actually not that hard, right? But actually, if you want to try to learn about the free body diagram, right? You can try to check with, try to start with this one. Okay, this is another problem, right? So blocks A and B each have a 2 kilogram mass. Okay, all contact surfaces have the same coefficient of friction. Okay, determine the force P needed to cause impending motion of block B. Okay, to the right if the coefficient of static friction is 0.3. So all the contact surfaces have 0.3 static friction coefficient. Okay, what we supposed to do about it? Anyone wants to help me about it? This is the last problem that we're supposed to discuss today. I think I will try to point out somebody here.
May I go again, sir? Because I think it would be good practice.
Anna, you already practiced for the previous one. I think it's better for you to point out somebody else to help me to do this. Who you want to point out?
I would like to point out
Who?
I would like to point out Adam, sir.
Adam. Okay, Adam. Hello, Adam. Hello, Adam.
Hello, sir.
Yeah. Because of Azer's request, please help me to do this, Adam. This is very simple, actually. It's just like a matter of creating the correct free body diagram for this one. Because the condition is impending motion. It's already stated that the condition is impending motion, and the static friction coefficient is 0.3 there. Okay. From where do you want to start, Azer? Adam?
Drawing the free body diagram, I guess.
Yes, of course. You're supposed to draw the free body diagram. Okay. Okay. We're supposed to start to draw the free body diagram. Actually, we can draw the free body diagram of both, right? Directly. So this is A. Okay, this is A. and this is P. Okay. Now what we have there? I think we will start at A first.
The weight, 20 newtons downwards.
20, yeah, okay, yes, use 20, 20 Newton downwards. What else? At B as well, it's supposed to be 20 Newton downwards, right?
Yes.
What else?
The normal force.
At A, the normal force, which normal force?
Is it between A and P?
A and B, okay. Where's the direction of the normal force?
Perpendicular
To the surface, right?
to the surface, yes.
Yeah, correct. So this one is normal force. And normal force and AB like that, okay? And what else that we have there?
The friction force.
What is the direction of the friction force there? At A.
Is it to the right?
Okay. In order to do that, right? It is better for us to draw the free body diagram. Why I draw it both right here? Because it is better for us to do it that way. Because we have P here going to the right. If we are taking a look, take a look at the free body diagram of block P, right? Then NA and NB and AB, right, is supposed to be action and reaction, right? Like that.
Yeah.
Okay. At B is supposed to be going downwards, right? Now at P, okay, what is the direction of the friction force? Because the P is going to the right.
So it's going
and
to
it's
the
in
left.
pointing motion. So it's supposed to be going to the left, right?
Yes.
So this one is supposed to be at friction AB.
And then action reaction.
Yeah, and then action reaction here, right?
Yeah.
It's supposed to be going to the right instead of to the left.
Yeah.
So always try to do it that way. Okay, like what
yes.
I did with Acer before. So try to take a look at the movement and then determine the friction force based on that movement. The same as at B, at the ground, there's supposed to be a normal force. Okay, normal force, actually I draw already, NB. And then there's supposed to be a friction force here as well. The friction force supposed to be going to the left, right? It's a FB like that.
Should that also be on the left side of A?
Yes, correct. The left side of A, there is supposed to be friction force as well. Okay.
Yeah.
So the friction force there, normal force and friction force as well, because all the force, all the contact is supposed, all the contact which is happening supposed to be having a friction force. Okay. So here the normal force is going to which direction? At the left of A.
Upwards.
No, normal force. Normal force.
Oh, normal force to the right, perpendicular
right,
to the
correct.
surface.
Yes. Why it's to the right? Because we have NAB. Okay, we have NAB, which is going to the left. So most likely it is pushing the block A to the left, which means we will have normal force here, NA, like this. Okay.
Yeah.
And then because the movement of the block B is going to the right, most likely because block B is going to the right, A will be going down, right?
Yes.
So the friction force is supposed to be going to the upwards, right?
Yeah.
Yeah. FA like that. So this is the free body diagram. Okay, and because everything is in pending motion condition, then FA is supposed to be 0.3 of NA. Okay, FAB is supposed to be 0.3 of NAB, and FE is supposed to be 0.3 of NB, like that. Okay. Okay, and FA is supposed to be 0.3 of sorry, F is NA, like that. Do you get it?
Yeah.
Then after this, we can try to calculate it. So the first thing that we're supposed to calculate is the first block, the top block. Okay, block A. By calculating block A, we will be able to get the value of NA and NAB, right?
Yes.
Okay, using sigma fxn equal to 0 and sigma fy equal to 0. Okay, after that, after getting NAB, we will go to the downward to the bottom one. We will be able to get NB and P. Okay.
Yes.
Okay. So that's the logic behind that, because for the top free body diagram, we will have two unknowns and two equation as well, sigma fx and sigma fy. Okay, the bottom free body diagram, we will have two unknowns and two equations as well. So something like this, right? This is the things that actually I draw like last year.
So could we go to the previous slide again?
Yeah, the same. This one.
For since we use 0.3 NA for FA, do we also do FAB equals 0.3 NAB?
Oh yes, correct.
Would that mean we only have two unknowns for each object?
Yeah, this one we have two unknowns. The top one we have NA and NAB, right?
I see, yeah.
The bottom one we will have P and NB.
Understood, yeah.
Because from the top one we only have two equations, from the bottom one we only have two equations as well. Okay.
Okay, sir. Thank you.
So you understand, right, how to solve this, right?
Yes, thank you.
Okay, good. Thank you. Just now Adam, right? Okay. Now I think this one, I believe you're supposed to be able to watch the video on about the tilting, okay, about the tipping, okay, the tipping condition. Remember, I think I will try to redo it a bit about the tipping condition, right? For the tipping condition, if the whole, but if the bottom of the structure, if the bottom of the structure all contacted to the ground, then the location of the normal force and the friction force can move. Okay, the location of the representative normal force and friction force can move, depends on the condition. Okay, but if like this one, okay, if it's like this one, then the friction force and the normal force only happen at point A and B only. Okay, the friction force and the normal force only happening at point A and B only. So it will not be able to move here at the ground here because there is no contact there. It's completely different because this one, the contact is only happening at point A and B. But for this one, the contact are happening at the whole bottom area here. So that's the thing that you're supposed to differentiate between those two. So please try to understand about that, and it will be slightly different for those two conditions. Okay. So try to understand about the tipping condition, and the explanation I already put it there in the video, and it's quite clear. Okay. For this one, it's slightly more difficult. Okay. For this one, it's slightly more difficult because there are two boxes, and I believe I haven't discussed it in detail, right? Yeah. There are two boxes there. Okay. And between the top box and the bottom box, there will be a friction force as well. Okay. Between the top box and the bottom box, there will be a friction force as well. And the location of the forces which is given is quite clear. There is 5 feet from the ground, and the size of the boxes both are 3 feet times 4.5 feet, like that. Okay, so basically what we're supposed to do to solve this is we're supposed to draw the free body diagram one by one. Okay. Okay, I think, and you can see here, the coefficient of static friction between the box is 0.65. The coefficient of static friction between box and the floor is 0.35. So it's slightly different, right? It's slightly different. So this is the things that you're supposed to do. You're supposed to draw the free body diagram of each, right? If we talk about the top box first, so this is the free body diagram. Okay, this is the free body diagram. Remember that it has a weight of 150 lbf. What else that it has? Then the force P is given here, around here. Okay. The force P is there. Then after that, we have a normal force here. Okay. We have a normal force here. We have a friction force here. Okay. That one. And this is normal one, friction one. Okay, then if we want to draw the second free body diagram, okay, there will be a action and reaction. Of course, the normal force will be going downwards, and one, and the friction force will supposed to be going to the right, friction one. And beside that, it has a weight of 150 lbf. Okay, and then of course it will have a normal force and friction force as well at the bottom. Like that. So that's the free body diagram of this particular problem. Okay. And the question here is the value of P, okay, the minimum value of P, which must be exerted by the man in order to create the movement, right? The value of P, which is supposed to be exerted by the man in order to cause the movement. So in this case, it's supposed to be impending motion, right? Impending motion, but remember, right? Impending motion there, okay, it's supposed to be only given to the bottom one, because the one that we are talking here, okay, we're supposed to check one by one whether impending motion is supposed to be given at the bottom one only, or both at the bottom and middle as well here. But because the friction force here, the friction coefficient is smaller at the bottom one, then we can check at the bottom one first whether the impending motion is whether that one is really happening or not. Okay, so we can check that the friction 2 here is supposed to be 0.35 of normal 2. Okay, by doing so, we reduce one of the unknowns there. Okay, then actually, because we want to find out the value of P, we can try to calculate from the bottom one first. We can try to calculate this particular free body diagram first. Okay. From this one, then how many unknowns that we have? N2, N1, and F1. Sorry, it's 3 unknowns. We have 3 unknowns, then okay. And this one, okay, using, actually we can just use combination, right? Using the first free body diagram, the top free body diagram, using sigma Fy equal to 0, we will be able to get that N1 will be equal to 150 lbf. Okay, N1 is 150 lbf. Using sigma Fx equal to 0, then what we will get is F1 will be equal to P. Okay, F1 will be equal to P. So we can use this two condition at the bottom one. N1 value is 150 lbf, and F1 value is equal to P. Okay. Whatever the condition is, F1 value is supposed to be equal to P, because the condition is impending motion. So the motion is not yet happening. So the friction force there supposed to be the same as the P value. So F1 value is the same as P. This one is equal to P. And N1 value is supposed to be the same as 150 lbf, like that. Okay, and then from this one we have P, we have N1. Okay, then N1 value we already have. F1 is equal to P. Then by solving this, we will be able to get the value of P. Okay, by solving that, we can try to, we will be able to get the value of P. Okay, although this one is with the assumption of tipping is not happening. Okay, tipping is not happening because it started from the beginning that it's the condition is in impending motion. Okay, the condition is impending motion because the least horizontal force P, the man must exert on the top of the box in order to cause motion. So condition is impending motion. Okay, now because of that, we have F1 equal to P, N1 equal to 150 lbf. Then using sigma Fy equal to 0, we will be able to get that N2 is equal to 150 plus 150 lbf. So N2 is equal to 300 lbf. Okay, and because it's impending motion, then F2 is supposed to be 0.35 of 300 lbf. So around 105 lbf. That's F2 because it's impending motion, right? Now, using sigma f x equal to 0. Okay, using sigma fx equal to 0, what you will get is f1 is equal to f2. Okay, which f1 is the same as p. So in this case, p will be equal to 105 lbf. Remember that this one is with the condition of tipping is not happening. Okay, because it started from the beginning. It stated from the beginning that the in order to cause motion like that. Okay, but if there is no information like that, and if you have to check whether tipping is happening or not, then what you're supposed to do is you have to calculate from the beginning whether tipping is happening or not. How to calculate it? The simplest way, right? In order to check whether tipping is happening or not, is just assume that the whole of this is one rigidity like that. Because why we can do that? Because mu s at this particular point is 0.65, and at this particular point is 0.35. Okay, so most likely, because of the horizontal force, everything, the slippage here will not be happening unless here is slipping first. So basically, we can just assume that there will be no slipping here before this one is slipping. So we can assume from the beginning, the easiest one is to calculate this as a whole structure in order to check whether tipping is happening or not. Okay, so basically we will have one whole structure like this, and the weight will be both, right? 300 newtons, 300 lbf. Then there will be a then in order to check whether tipping is happening or not, okay, so the weight will be here will be 300 lbf. Then there will be a force here, P. Then there will be a normal force and friction force. Okay, normal force and friction force. So if tipping is happening, right? Wait a minute. This one, normal force, friction force. So basically, we can try to calculate the whole things by using this particular free body diagram. So if we want to check the condition of impending tipping, we can assume that the friction force happening at the edge and normal force happening at the edge here. Normal force, friction force. Okay, so basically is that one. So we can check whether the tipping is happening or not is based on this one, this particular free body diagram. Okay, so the way to check whether tipping is happening or not, right? It will be the same as the way to check whether tipping is happening or not for this particular point. For this particular case like that. So we have to check. Okay, we have to check whether the x there. Okay, we have to check whether the x there, the x which is happening there, right, is supposed to be. So we can check here. Because if tipping is happening, sorry, I think I will redo this one. Oh, we will still have 3 more minutes. Aduh. Okay, P is here, the weight is 300 lbf. Then we have a normal force and friction force. Normal force and friction force is supposed to be happening at x direction from the weight like that. Okay, and the P is supposed to be here. Okay, and then this one, the friction force here, is supposed to be the same value as P because it's supposed to be not moving at all, right? That's why now it depends on the moment due to the 300 lbf, and normal force using sigma Fy equal to C is using sigma Fy equal to 0, we will have normal force equal to 300 lbf. Using the sigma Fx equal to 0, we will have F equal to P, right? Using sigma moment, then if we know the value of P, okay, if we know the value of P, we will check this one, X. Okay, we will check this one, X. We can check the X value. If the value of P is 105 lbf, so the friction force here will be 105 lbf based on this one. Okay, P here is 105 lbf. Okay, so we can check whether the couple due to the friction and the couple due to the this one, okay, will give X bigger than 1.5 feet. Because if X is bigger than 1.5 feet, it means that the friction and the normal force is already outside of the box, which means it will be tipping. Okay, so we can check the moment due to the P, sigma moment equal to 0. Then the moment due to P is 105 multiplied by 5 feet clockwise. Okay, and the moment due to the weight and the normal force is 300 multiplied by X equal to 0. So in this case, we can calculate that the X value is equal to 525 divided by 300. So the X value there will be, what is the value there? 525 divided by 300. 1.75. Okay, 1.75 feet. So you can see that the X value is 1.75 feet, which means it's already outside of the box there, because here is just 1.5 feet. So the force is supposed to be here. The normal force and the friction force is supposed to be here, which means that in order to make everything in balance, okay, in order to make everything in balance condition, okay, and in order to impending motion to happen, right, the force 155 lbf is supposed to be given in order to create an impending motion condition. But because of this force 105 lbf, right, the X there will reach 1.75 feet, which is outside of the box, which means that it will tip over. So the conclusion here is, if we want to push the box, okay, it will tip over first before it moves. So the conclusion that we will find out is it will tip over because of this, because of the calculation here. Okay, because of the calculation of X there based on the pushing force which create the impending motion. I think that's all the discussion for today. Hopefully it reached you well and you understand about this tipping problem. Okay, I think that's all, and don't forget to prepare well for your exam tomorrow. Okay, I think that's all for the discussion today. See you guys again tomorrow morning. Okay.
Okay, thank you, Pak.
Thank you, Pak.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, Pak.
Thank you, sir.
Yeah. See you guys. See you again tomorrow.
Thank you, sir.
Yeah. Bye bye.
Thank you, sir.